Till now we have discussed the basics of PN junction diode, also the equivalent model of PN junction diode, ideal model, practical model, also the piecewise linear equivalent model. These are the approximations of model. Okay, now we shall discuss the DC load line analysis of diode. So to draw the DC load line analysis, to make the load line analysis of diode, we'll take the diode circuit here. So what is the circuit? We have a diode D1 here, which is connected. So this is anode terminal and this is cathode terminal, correct? So the anode or the P, usually we call it as P type, P end, correct? So the P side of the diode is connected to the positive potential of the battery here, and the N side is connected to the negative potential of the battery. So what are we doing here? We are forward biasing the diode, correct? And that we are doing through a current limiting resistor, which is called as R1, which is 100 ohm, and we are connecting it to a battery. So overall, basically we are forward biasing this diode. Okay, so now apply this is the VI forward biased forward characteristics of the diode. This curve is the forward characteristics of the diode, and the line whatever I have written, and now I am explaining how exactly we draw this DC load line. Okay, so apply KVL to this here. So you substitute Vf is equal to 0. So if Vf is equal to 0, what do you get? E is equal to what? If into R1, that is IE is equal to VR1. Rewrite this equation for IF. You substitute Vf is equal to 0 and write this equation for IF. So what is IF? E divided by R1. So E divided by R1. So this when you are getting, when you give Vf is equal to 0. Correct. Okay. Next, so when you give Vf as 0, what is IF? What is the current? This is the current line. What is current? Current is how much? What do we get? E by R, R1. So that you are going to mark it here. So this is the point where you get E divided by R1 in that equation. Correct. This is when you give Vf is equal to 0. So I get a point. Approximately I am marking it on my y-axis. In the same equation, you substitute IF is equal to 0. So what do you get if you substitute IS is equal to 0? You get E is equal to what? Vf. E will be equal to Vf. Okay, that is the point here. Okay, understood? So when your current is 0, the voltage whatever you get, that you're going to mark it on the x-axis. When you give voltage as 0, the current whatever you get, that you're going to mark it on the y-axis. Join these 2 points, that itself is your DC load line. Is it clear? That is the DC load line of a diode. So for any circuit, you can mark the DC load line in the same way. Exam, you will be asked to solve a circuit and also draw the DC load line. In a similar way, you have to do it. Okay. If you substitute for E, E will be given to you. Substitute for R1, you get a value on y-axis. Whatever E you have, the same will be marked on x-axis. Join those 2 points, and the DC load line, wherever it meets this is the forward biased characteristics of the diode. Wherever it meets these 2 points, these 2 curves meet, and this is called as quiescent point. The point of intersection on is the point of operation, which is usually called as quiescent point. Okay, the straight line drawn between the 2 points is the DC load line. This is the straight line which is drawn between the 2 points. That is DC load line, and this is the point of intersection of your forward characteristics of the diode, and your DC load line is called as quiescent point of the diode. Okay, so in the next class, in the next video, we'll see the applications of diode. Okay. We'll discuss the Zener diode. Then we can see the applications of diode. Okay, in the next class, we'll discuss. Fine.